The term extraterrestrial refers to things of or from outside the Earth or its atmosphere, life forms that did not originate and are not indigenous to our little blue planet. So, by definition, this term covers all types of possible life. Outside the Earth, this could mean viruses, bacteria, plants, intelligent and unintelligent life. Of course, the big-ticket item here is intelligent life. Similar to humans, they are complex, innovative, and probably far more intelligent. We know them as aliens. But if there are aliens out there, why haven't we heard or found them by now? Half a century of space exploration and we haven't come close. The universe is vast and infinite. How could we possibly be the only forms of life? This is the Fermi Paradox. The conflict between the lack of clear, obvious evidence for extraterrestrial life and various high estimates for their existence. Perhaps the problem lies in our method of observation. The Fermi Paradox. As I've said, the Fermi Paradox represents a thought of the physicist Enrico Fermi. The conflict between the lack of clear, obvious evidence of extraterrestrial life and various high estimates for their existence. In 1950, Fermi assumed that if there were some forms of extraterrestrial life or aliens, then advanced colonies should have made it possible to survive millions of years. During this time, it should be possible to colonize complete galaxies by means of intergalactic and interstellar space travel. Fermi went even further by assuming that this probably had already happened. Nevertheless, the search for aliens has been unsuccessful so far. Any true scientist or astronomer would agree that there is some form of alien life out there. Even the most hesitant of them would agree that bacteria or plant life has to form on some far-off exoplanet. We just haven't been able to prove it yet, and this is paradoxical. This was when Fermi began to question his observations and assumptions, which led to the Fermi Paradox. Since the universe is already very old and has many stars, there should be life beyond the Earth, unless the origin of life on our Earth was an extremely rare process, also called the rare Earth hypothesis. It can be assumed that Earth does not have a unique position in our solar system. Logically speaking, there should be other technical civilizations in our galaxy. Although the galaxy itself has a width of about 100,000 light-years, that would mean that anything less than light speed would need almost 10 million years to travel such a distance. Although, because of this, one can conclude that the galaxy is about 10 billion years old. If there is a civilization in the Milky Way that is capable of interstellar colonization, then the whole galaxy could be completely colonized in only a few million years. The Milky Way is much older, therefore extraterrestrial life should exist somewhere in the neighborhood of the Earth. With that being said, to this day, there is no proof for extraterrestrial life. In a nutshell, the paradox claims that if there is extraterrestrial life out there, why haven't they reached us yet? Enter the Drake equation. The Drake equation is closely related to the Fermi paradox. While most of the parameters of this equation are unknown and it cannot solve the paradox, it is still a helpful tool for theoretical thought experiments. The Drake equation only refers to the Milky Way, our galaxy. We have found that the Milky Way is a barred spiral galaxy, which is about 2/3 of the galaxies existing in the universe. Since the universe, as observed today, has up to 100 billion similar galaxies to the Milky Way, the final value resulting from the Drake equation would have to be multiplied by a relative factor for the whole universe. Although this increases the total number of possible civilizations enormously, this calculation remains very imprecise due to the insufficient knowledge of other galaxies. In addition, the Drake equation refers not only to the theoretical number of civilizations, but also to the possibility of establishing contact with them. Our closest neighboring galaxy is the Andromeda Nebula, which is 2.5 million light-years away. So, this galaxy is already out of consideration for practical contact and, consequently, all others as well. In layman's terms, we may not be alone in the universe, but we might as well be. One thesis says that multicellular life in space is very rare, since even Earth-like planets are rare. If you think about it, not only were the conditions to create the planet Earth very rare, but the improbable coincidences that occurred so that life could form were also extremely rare. More than that, the process of evolution took billions of years, and we are the only animal on Earth that turned out intelligent. By relation, the existence of other Earth-like planets is also improbable. These coincidences include the existence of the Moon and the position of the Earth in the solar system. The likelihood of all this happening is 1 in a billion. Although the universe does have the numbers to recreate that 1 in a billion chance of life, it would be few and very far between. In this explanation attempt, the parameters of the so-called Drake equation are chosen in such a way that in the galaxy in which we find ourselves, only our civilization exists. Thus, the Fermi Paradox no longer becomes paradoxical because one of the basic assumptions is negated. However, there are scientists who believe Earth-like planets do exist, especially since more and more exoplanets are being discovered to support this assumption. Impossibility of interstellar colonization. The prerequisite for the Fermi Paradox is a civilization capable of colonizing interstellar. However, this cannot be fulfilled on principle because, with this precondition, it would be possible that there would be some super-technical civilizations, but they could not influence each other because the spatial distance would be too far. For example, the distance of the Sun to the star Proxima Centauri, the nearest star, can only be reached after several years of traveling, even at the speed of light. The thing is, even the speed of light cannot be exceeded. This leads to several questions about the practicality of interstellar travel. For one, the question arises whether a civilization could still reach a foreign star system and if this would be even advantageous for the civilization. On the other hand, there is the question of what kind of exchange among populations from different star systems would be acceptable in order for a civilization to have proper cohesion. According to Stephen Hawking, the origin of life outside the Earth is probable. More so, he also believes that human-like intelligence is possible. However, he assumed that this intelligence would eventually reach a limit and become unstable, so that these organisms would unintentionally extinguish themselves. This makes sense, considering humans are in the process of ruining the Earth as we speak. This could be triggered, for example, by genetically manipulated viruses, nuclear wars, or a greenhouse effect that can no longer be controlled. Now let's move on to the darker and more realistic reasonings to why we haven't found aliens yet. Berserker theory and dark forest theory. The Berserker theory, named after Fred Saberhagen's Berserker saga, assumes that aliens send artificial probes into space that destroy other civilizations. In doing so, they deliberately destroy other life so that potential enemies are eliminated early on, allowing the aliens to spread out into space undisturbed. There are different opinions concerning the way of extermination. The Dark Forest theory, named after Leo Sishin's trilogy, The Dark Forest, aims in a thematically similar direction. According to this theory, extraterrestrial life does exist, but these civilizations camouflage themselves and behave inconspicuously so that no potential enemies will notice them. This is intended to reduce the risk of predation, similar to camouflage in biology. According to this, the universe is a dark forest that is home to all kinds of predators that compete for the best camouflage. Astrophysical explanation. Gamma-ray bursts are now considered the most energetic phenomena in the universe. This is because gamma-ray bursts can cause mass deaths in planets that are located within their cones of radiation. Even light years away, higher life could also have been extinguished by them. In other galaxies, evolution to complex life forms is said to have been impossible in the first 5 billion years of the beginning of the universe because of intense gamma-ray activity. The mathematical a priori argument. The astrophysicist J. Richard Gott does not consider the thesis that galaxies are colonized to be tenable, because he believes that all life would then be part of such a super civilization. If civilizations like that existed, then according to the astrophysicist, it would be unlikely that we were formed on the comparatively young and small Earth. which at that time had not even been colonized. Meaning, if the colonization was real, then we would most likely have missed it. The Great Filter concept. The concept of the Great Filter combines some of the above arguments. This concept says that there is a kind of filter that is necessary to reach a level of civilization. This filter would present a hurdle or challenge that would make it very difficult to reach the next level of civilization. It is possible that higher intelligence is very rare in evolution. With this assumption, we humans would be the only life form that has overcome the Great Filter so far. With this possibility, other civilizations would have failed to overcome the filter, and mankind would have to be the first to overcome it. Another problem in astrobiology is that there is no general definition of life. Several attempts have been made to define life, but no definition has been complete or satisfactory. This means that there is no fixed division between living and not living. Even if there is life similar to that on Earth, it still has to be clarified whether this life originated on Earth and then spread in space, or whether it developed in another place independent of our Earth. What do you think? Do you think that man and our Earth are unique in the universe? Maybe our origin is nothing but a very improbable coincidence. The topic of aliens will surely be a topic of debate for many years to come.